Hello, everybody. Uh, Today is Thursday, January 11th, and this is the first episode of zkSNACKS, an experiment we're trying out with kind of shorter formed, more concise format. So we'll see how you guys like this. But sticking with block digest tradition, me and Janine are joining you today at block height 503,769. So, I guess you wanna go into a little bit about what we were thinking, playing around with the new format, Janine?
Yeah, so the reason it's called zkSNACKS is just because we kind of wanted to make it's kind of similar to zkSNARKS, but we wanted to keep snacks because it's kind of sticking with the theme of block digest, like digestion and food, I guess. It kind of goes together. We haven't really come up with a explanation for what the acronym stands for. We've come up with a few ideas like savory nutshell assessments of crypto knowledge significance. But then we added ZK at the beginning to obviously make it like zkSNARKS. But perhaps maybe in the comment section, you could help us out with that, coming up with an explanation for the acronym. But yeah, Shinobi said we're trying out this shorter format so that we can get more detail in one story. But if you also still like the long form content, we'll be doing the regular Block Digest show about 2 or 3 times a week. And as we mentioned at the end of our last Block Digest episode, number 70, Bitfury Group announced on January 4th that they have, quote, a new solution to help reveal relationships between Bitcoin addresses that is in data and ensures greater accuracy in linking Bitcoin addresses to for the purpose of aiding investigations and reducing criminal activity. Now, rather paradoxically, they also say that they will be showing Bitcoin users ways to protect their privacy, which I think is interesting because they actually don't provide any kind of guide for that whatsoever in the white paper. Because as you know, most Bitcoin users will probably not be very technical, and so they're not going to read this rather complex white paper. They need very clear guidelines for it to be effective in helping them with their privacy. So they haven't done that, which is not surprising to me because it's kind of, an opposing interest of working with law enforcement, to be honest. Speaking of which, they include a quote from one of their new advisors, Jason Weinstein of Steptoe & Johnson LLP, who is a former deputy assistant attorney who was in charge of the cybercrime division of the U.S. Department of Justice. And if you've been paying attention to all of the drama around exchanges, especially in the last year, you'll probably recognize those names because it's the same law firm that Bitfinex announced they had hired at the end of last year. Bitfinex is a part of the Blockchain Alliance, as is BitGo and Blockchain Data and Phone, and a number of other companies that you probably use and maybe you're freaking out a little bit right now. It's basically a coalition of companies that, quote, serve as a resource for law enforcement and regulatory agencies, and Steptoe & Johnson act as counsel for that coalition. So the revolving doors kind of spin round and round, don't they? And unfortunately, it's a pretty sad day for privacy rights today because the U.S. House of Representatives just voted against the USA Rights Amendment. Instead, they voted to approve reauthorization of the Foreign Intelligence Surveillance Act, aka FISA, which, despite what the name implies, is actually allowing for warrantless surveillance of American citizens and not just foreign nationals. Well, I guess on the bright side, it was nonpartisan because Democrats and Republicans voted in favor of reauthorizing it. And kind of weird because, Democrats have this weird habit of declaring that Trump is a tyrant most of the day, and then they simultaneously vote to give him more power. It's weird how that works. So Shinobi, do you want to start off with the on-chain heuristics aspect of the paper?
Mm-hmm. So pretty much the innovation or new methodology Bitfury is introducing here is kind of combining analysis of purely on-chain data and refining it with off-chain data. So I'm going to go into the 2 heuristics they use to analyze the on-chain data, and after that, Janine can dig a little into the off-chain data that they bring into the picture. But one of the first things that they do is they break things into 2 heuristics they use, which are intentionally constructed in a way so that for any given transaction, only one of them can be true. And so the first one of these is called common spending. And pretty much the conditions for this are pretty simple. It is a transaction that combines outputs from multiple addresses and has exactly one output in the transaction. And what this kind of, proves, I guess you could say, is that a single entity controls all the addresses providing inputs, because the situation where you would have multiple people crafting a transaction, sending everything to one place, it involves such a high degree of trust that that's just statistically unlikely for the supermajority of transactions that fit this pattern. Effectively, this is the first heuristic they use. And the second one is a little more complex. It's called one-time change. And pretty much what this is trying to do is identify a transaction that shows a likelihood of being controlled by one individual as well. And this is a little more complex in the criteria. First off, it has to have exactly two outputs in the transaction, because obviously, one person would be making their payment and then sending any excess not going to the fee back to themselves to a train address. The second criteria is that any transaction that has exactly two inputs is considered invalid. It is not a pass for this heuristic, because that sort of implies, the potential of two people mingling inputs and then each getting their respective amounts back through the outputs. And so that rules it out. And as well, there are two strict criteria for each of the outputs. One of the outputs pretty much has to be spending to an address that has seen a balance or use on the blockchain before, indicating that this is actually something being used for regular activity. And two, that output cannot ever once have been flagged under the pretty much what would be recorded as a change address. And then the second criteria for the other output is that output has to be going to an address that has never been used on the blockchain and never flagged as a change address previously, and have an amount that is set to some arbitrary limit, showing that it's something with actual value. And so in this way, they can kind of, because of the way wallets are structured and how change addresses are generated and kind of handled differently than other addresses, use a process of elimination to once again take a transaction like this and with a very high degree of certainty say that it's controlled by one individual. And as I said, part of the innovation in their methodology is combining that with off-chain data, which Janine can go a little bit into now.
Yeah, so I first wanted to point out that one of the things they specifically noted in their Medium post was that they use clustering. That's the main technique they're using. And I thought it was interesting that they made it sound like they had invented clustering, because they say in the Medium post, the ability to link related addresses called clustering is an important new tool that helps law enforcement. So that makes it sound like their tool invented clustering, and that really makes me suspicious, because they did in fact not invent clustering. Most of the blockchain surveillance / analytics companies that have been going up in the past several years, most of them use clustering as an analysis technique. So Bitfury did not invent clustering. Maybe they improved the process, but they definitely didn't invent it, which I find a bit weird that they kind of imply that they did. So section 4 of the paper addresses how they passively or actively, as in manually, like going with a person looking for data, how they collect off-chain data in order to increase the probability that what they found with the on-chain data is correct. And one of those ways is to simply crawl public forums like user profiles and darknet marketplaces. And yes, darknet marketplaces are public because they're not private, as in you can access them via the public web just by using the Tor browser. And they specifically list Bitcoin Talk, Twitter, and Reddit as some of the examples, but you can assume that pretty much any social media site, especially one that is known to have a high concentration of Bitcoin users, will probably be targeted for this. They're particularly interested in the so-called darknet marketplaces because, especially if that data gets hacked or dumped elsewhere in the dark web, they believe that's, or I assume they believe that data is most likely to be involved with or point to criminal activity. Another way that they tie off-chain data on-chain data is that they'll look for addresses which use unique prefixes. So as you know, it is possible to generate what are called vanity addresses, which add a human-readable kind of stylized set of characters at the beginning of a Bitcoin address to make it identify with a particular person or company. For example, Andreas uses one Andreas. The browser wallet ProTip uses one ProTip, etc. At the beginning. Some people do that just for fun. They might use their name, or as we say with some exchanges, they actually use that vanity address for their exchange, which makes it really easy to identify, the funds that exchanges are handling. Some people do that just for fun, and others use it as a kind of safety measure against someone spoofing their website and putting a fake address where people could possibly send donations to that spoof website. Because in order to generate that specific address, you have to expend a lot of energy in order to create it in the first place. So it's a lot harder to fake. But yeah, I think that's essentially what they've provided in the off-chain data section. Essentially web crawling, which isn't very new.
But the one thing that really kind of bothers me is mostly the methodological way that they're kind of using all of this, because most blockchain analytics pretty much has just it just takes the on-chain data, and then from that point, I assume, looks for metadata after the fact, and then kind of draws conclusions from where the on-chain heuristics lead them. And one of the things that Bitfury is doing is kind of doing that more real time as they construct the model. And so one of the things they've done is taken all of these off-chain data tags and kind of classified them under different categories, like services, gambling, mixers, darknet markets, exchanges, and mining pools. And they've kind of constructed a logic to use this as a metric to invalidate what would be considered valid address associations just looking at the on-chain data. And one of the ways, if you'll notice, going diagonally down this chain, or this table, sorry, you'll see that there's Fs all the way across. And that's because, obviously, let's say you have an address definitively tied to Coinbase. Well, that address can't be controlled by another exchange like Bitfinex. So you can rule out any kind of erroneous connections there. And they've also gone a step further to kind of look at what other things you can exclude just through logic. Like, for instance, a darknet market is not going to be the same. You can't have an address that's validly controlled by a darknet market operator as well as an exchange. So that's going to be ruled out immediately if the on-chain data kind of leads them to that conclusion. And pretty much what they'll do is they establish kind of an ability to weight these off-chain tags using this kind of set logic here. And what they'll do is they'll start off and maybe model things with absolutely any contradictions according to these tag labels immediately ruled out. And then they'll kind of increment up and let more and more of these these erroneous connections that should be filtered out by their tag logic to be let into the model. And in that way, they can kind of increment through the different kind of associations that you would immediately rule out by logic, but you might find other reasons for it, and kind of make a more fine-grained model of what addresses are most likely controlled by a single entity by using this off-chain data and constructing the model. And that's something that it should be kind of terrifying, because people have been saying this kind of stuff for years. Anything you do on the blockchain is going to be there forever. So at any point, the more tags that they can refine for this, and again, they didn't even mention in the paper anything like exchanges and their internal data about who they're sending money to for withdrawals and such. But you can really start narrowing down a lot of ownership for different coins over time, the more you refine a model like this.
Yeah, and especially if anyone is using services that do something unique with how they handle transaction processing. Like, for example, we saw BitPay a few months ago that a user was reporting that they were putting data in the op return field, which is very identifying because any user who is then sending transactions from what can be linked back to BitPay, then you'll know that that user was using BitPay. And so, and also the reason it was bad is because it increased the transaction fees that those users had to pay, because obviously that's extra data. It increases the transaction fee because transaction fees are based on the size of the transaction and not necessarily the amount. That's a common misunderstanding, but obviously it has privacy implications as well, because if you're marking, if you're putting data in the op return field, that makes it stand out in the blockchain.
And I mean, like the only real one ray of hope that I can take away from this is ultimately how effective it was. Real quick, let me get this up on screen. Pretty much what they did was they tested this for all chain data, pretty much from the Genesis block up to March of last year. And they were only able to cluster under their model about 1/6 of the entire blockchain. But I mean, like I was saying earlier, with the way that you can kind of keep iteratively improving the error rates of modeling like this, I mean, that's still kind of scary. And like over time, that's just going to be a bigger and bigger chunk of the blockchain's history, that they are more reliably connecting to like this group of coins is one actor, and we can say that definitively. And like Janine said, Bitfury tried to kind of go, we're showing users how to protect their privacy, but they didn't actually go into any advice about how to do that.
Yeah, so I am kind of glad that they were only able to cluster that's less than 20% of addresses. So I guess that's I mean, it could have been worse, but yeah, it's definitely going to get worse over time. And let's see, I think we should go into, there are a few things you can do to mitigate this a bit. For one thing, you don't want to use services, for example, ones that are part of a blockchain alliance that implement a lot of KYC procedures. But the side note of that is that there are some things that they may be doing to KYC you that you're not aware of, like browser fingerprinting, which is something that Coinbase does and probably a lot of wallets do, which is, it shouldn't be something that they're doing. Because it's very identifying. It's actually worse than cookies if you understand what browser fingerprinting is. Because I know for a fact that a lot of exchanges, if you even use them once, they're going to store that data forever. So they're going to know what browser you use, they're going to know your operating system, they're going to know your IP address, and they're going to store that forever. A lot of exchanges that are implementing KYC compliance things, they keep all of that data. And it's really unfortunate because, especially, as you saw with Coinbase, they're going back through their transaction history, and all of that information is going to be going to the IRS, regardless of whether you were compliant or not with, or whether you're a U.S. citizen or you're compliant with IRS tax law. So if you do use exchanges or services that require KYC, you have to be aware of, managing outputs so that you don't make it obvious that, like, maybe you have a section of Bitcoin that you haven't sent to an exchange, and so it hasn't been linked with your identity. You don't want to be mixing those Bitcoins in, like, as Shinobi calls it, the non-doxed outputs. You don't want to be mixing those together. And you also want to increasingly use wallets that actually protect your privacy, like Samurai. Electrum also has a privacy setting for change addresses that will allow you to set multiple change addresses, which is good. And yeah, you should also, well, one of the things I wanted to kind of think about is because if they're using like an automatic analytic process like a web crawler. That means that they're not actually going to people's individual websites where you may have a Bitcoin address there, if you want donations for your work. And, one of the things that people do is that they actually set their website so that it can't be crawled. So that means it won't search engine, which you may not like, but if you care about privacy and you just want to put up a website so that you can have it on your profile somewhere else, that means that your website can still be visible, but a crawler won't necessarily catch it because robots.txt, which is what most of them use, actually prevents the web crawler from gathering data about your website unless someone manually comes along, or they ignore robots.txt, which is possible because I believe that's what archive.is does. It doesn't actually follow robots. So, but if you do have a Bitcoin address on your website, say, you could possibly improve your privacy slightly by making it not possible for it to be crawled.
Mm-hmm. I mean, really the only thing I have to add there is like pretty much any coins I've ever received from somebody by putting an address online publicly, I consider those their own little silo. Like I never mix them with other coins I bought from some place like Coinbase. I don't mix those with other isolated sets of coins. Like that's its own little wallet. And I pretty much ignore it unless I can think of something to use that isn't going to dox me, that isn't greater than that value. And when you're dealing with things like Electrum, it's just remember that the more outputs you create, that will incur a cost and fees. But I mean, ultimately, that just comes down to, how much you as a user value your privacy. I mean, if you do, I mean, there's a cost to pay for everything. But personally, I think it's worth it.
Yeah, and there's also actually a security benefit as well to not reusing addresses, as in, you have Bitcoin that goes into address, and then when you want to spend it, you spend it immediately. And the reason why there's a security benefit is, you probably heard this before, but if quantum computers or ever come out that are able to break Bitcoin's encryption, like SHA-256, which actually wouldn't even require a quantum computer necessarily if they just find enough collisions. But if SHA-256 ever gets broken, Bitcoin has a bit of a buffer because the wallet, the public key is actually not exposed until you spend the Bitcoin in an address. So if you only use an address once, then by the time you've spent it, the public key, if the public key gets revealed, there's no like security loss from that because you've already moved the funds out of the wallet. So privacy and security are kind of interlinked. So it would be good to, that's why I'm excited for things like MAST and Lightning Network to come out, because that'll improve privacy.
Mm-hmm. So I guess, to kind of wrap things up, guys, I hope you found this enjoyable and useful. And for the brave souls who are not that mathematically inclined, that want to dig through the paper, my advice is just find like a picture or a diagram for set theory notation. And that should be really all you need to kind of pick through if you're willing to sit and think about things for a minute. But I guess, any last thoughts do you need?
Yeah, just this is the first time that we're doing this short form show, so let us know what you think about it, and if you enjoyed, if you like it being shorter, and what we can do better, and also make suggestions for what the zkSNACKS acronym should stand for.
Yeah, I'm kind of interested to see what people think about that. But so I guess we will be back with our next full episode and the full cast on Saturday. I guess toodaloo, people. Like it if you like it.